Hello and welcome to all who are watching. In this video, we'll explain the fundamentals of programming with the Perl language. We'll go through the basics and hopefully encourage the viewer to personally seek out more resources on and about Perl. But first, a simple introduction. Perl is a general-purpose programming language, which means that it is not confined to a specific domain. Its interpreter was developed in 1987 by Larry Wall, who we'll talk about briefly in a few minutes, and it is available on a variety of operating systems. It actually comes pre-installed in most Unix-based systems. In the next 30 minutes, we'll talk a bit about Perl's creator. We'll cover its main purpose, we will provide a tutorial that will assist the viewer in downloading and installing Perl, as well as cover Perl's general syntax, including variables, expressions, statements, blocks, comments, and whitespace. We will also cover the necessary instructions for control flow, including conditional and loop statements, in addition to a basic overview of the simplest data structures that Perl has to offer, arrays and hashes. Perl's creator Larry Arnold Wall is an American computer programmer and author. He is the author of the RN Usenet client and the widely used Patch program. He has won the International Obfuscated C Code contest twice and was the recipient of the first Free Software Foundation Award for the advancement of free software in 1988. Wall developed the Perl interpreter and language in 1987 while working for System Development Corporation, which later became part of Unisys. He is the co-author of Programming Perl, often referred to as the Camel Book, which is the definitive resource for Perl programmer, and edited the Perl Cookbook. He then became employed full-time by O'Reilly Media to further develop Perl and write books on the subject. The beginning intention of Perl as a general-purpose scripting language in Unix, the process reports easier and faster. The language grew from its niche as a tool for system administrators, however, who needed something more powerful than shell scripting and easier to use than C programming, into a general-purpose programming language. Perl has a solid history of pragmatism and, in recent years, a disciplined approach to enhancement and backward compatibility. Over Perl's long history, Perl 5 has been continually refined over the past 30 years. Our understanding of what makes great Perl programs has changed. While you can write productive programs and never take advantage of all the language has to offer, the global Perl community has invented, borrowed, enhanced, and polished ideas and made them available to anyone willing to learn. But important questions still stand. Perl gets things done. It's flexible, forgiving, and malleable. Capable programmers use it every day for everything from one-liners and one-off automations to multi-year multi-programmer projects. Perl is pragmatic, you're in charge, you decide how to solve your problems, and Perl will mold itself to do what you mean, with little frustration and no ceremony. That is a snippet of what the Perl philosophy entails according to Chromatic. Perl prides itself on its flexibility rather than elegance. It is an incredibly diverse language that allows the user to take what they need without much hassle. Perl was originally developed for text manipulation, but now it is used for a wide range of tasks, including system administration, web development, network programming, UI development, and more. Language is intended to be practical rather than beautiful. Its major features are that it's easy to use, supports procedural programming, has powerful built-in support for text processing, and has one of the world's most impressive collections of third-party models. So simply put, Perl's main role is text manipulation, and no other programming language provides more powerful or easy-to-use ways of doing so.
Hi, in this tutorial I'm gonna show you how to install Perl onto your computer, as well as guide you through the procedure of writing your first script. Perl, just like any other language, needs a compiler. In most Linux distributions and iOS operating systems, you are most likely to have it already integrated into your system. However, for Windows users, you will have to download it. And to prove that, I will open a command prompt shown over here, and I will write the following command: Perl space dash v. This command over here is supposed to show me the current version of Perl installed in my computer. As you can see, it is not recognized. However, when I go to this virtual machine, which I have GNU Linux operating system on it, and open the terminal, write the same program v, it will give me the actual version. You can see this is Perl 5 version 32 subversion. Anyway, uh, To download Perl onto your computer, you will have to go to this website, perl.org. Now, this website is a gold mine. It is the main website for Perl. It's where you can find basically anything concerning Perl, where they might be learning its basic syntax and its uses. Actually, we were mildly inspired from this website, and it saved us a lot of time and effort uh, throughout this course. So we'll be mainly drawing most of our syntax from this website. Anyway, to download the latest version of Perl, Linux, Mac OS might also not have the latest. You, uh, you can see over here how you can download active Perl or latest stable source for Unix, Macintosh, now to Windows. For Windows, we will be using Strawberry Perl, as if it is most easy to use version. You can also download active Perl. There are also other versions. There is the Padre, which is somewhat of a IDE for Perl. However, in this version you can only get the version 5.14, which is good in itself, but does not contain the latest syntax upgrade. Hence, we will be using the Strawberry version, and that's over here. Now, depending on your system, you can whether download it on 32-bit or 64-bit. You press on it, and you should have it installed over here. Now that I already have it installed on my actual computer, I'm gonna uh, install it. So I'll see you guys back in a bit. Now, with that out of the way, you will be greeted with this app over here, Perl command line. And once you open it, you start to see that it's really similar to your command prompt. Actually, it is practically the same thing. Just so now we actually have Perl installed in our system, so that when we run the command perl-v, it actually shows us the current version of Perl successfully. And with that, we can compile and run our Perl programs safely and soundly. Now, when it comes to text editors, actually there are surprisingly very few text editors that could understand Perl syntax. One of which that we found is Code Blocks, as you can see here. Which is a free software, and it contains pretty much any any programming language you wish to use. And once you scroll down over here, we can actually see Perl over here, and you can start programming as you wish. The second text editor is actually Notepad, the one that we'll be using throughout this course. And lastly, the ones also found is Padre, the IDE I mentioned earlier. There may be, of course, more text editors, but unfortunately, these are the ones we found. Now, let's get on with this and let's write some programs and run them. Now, when creating a program, it is essential to say the use keyword. Actually, I have to set up the language. We choose P Perl. Great. As you can see, it becomes highlighted. And once we use this keyword, we have to mention right in front of it the Perl language. In our case, it's 5.32.1. And now we print a random line. Let's say hello, smiley face, close, and we save. Hello, and we have to, and every single Perl programs must be finished with PL at the end. Documents, it's easy to access. Now we go to the command prompt, we write Perl and hello, and it runs successfully. Now, why it's crucial to know about this use keyword? It's because actually we can use previous versions of Perl in this very same program. I can use the very first vanilla version, like 1.0. Save, command prompts, and it runs successfully. But now, when I remove print and replace it with the keyword say, it wouldn't work. Oh yeah, didn't save. Yeah, as you can see, it doesn't work. But when I implement the latest version, which is version 5.32.1, and save, cls, run, it works. Hi, in this tutorial we're going to have a look at variables, but before we jump into it, we should first familiarize ourselves with Perl's basic syntax. Now, as you can see, the statements are written in a straightforward fashion, which implies that we don't need to have a main function or anything of this sort, but we do need, of course, to end our statements with a semicolon, except for the very last statement when it's not mandatory, and I'll show you why exactly. We have here a program that prints hello, smiley face, and right next to it a next hi, next string. Once we run this program, it's gonna run successfully, and once we remove the semicolon, the very last statement, it will still work. Okay, now for comments, they begin with a hash symbol, and we can write our comments that this is a comment. We save, and it would still work. Now, when we put this hash symbol, the comment written over here will only run through the whole line, but once we jump down, it wouldn't consider it as a line. This is no longer a comment. As you can see, it's not highlighted as a comment. It's gonna run through its default state. Now for white spaces in Perl, they are practically irrelevant except for inside quoted strings. For example, over here, if I jump down over here, we're gonna have a different program as of previous programs. As you can see here, hello, hi. But of course, once we remove, we can just do this, and it will run just fine. For variables, there are three main types of variables: scalars, arrays, and hashes. For scalars, you declare them with the dollar sign, and then you type the name of your variable, say my variable, and you can either declare them directly over here, and it will become a global variable, let's say 2, or you can declare them with the my keyword. The difference is that when you remove this my keyword, it becomes a global variable, but when you don't, it's a local variable. Now, what's interesting about scalars in Perl is that these values, they can be uh, anything really. They can be an int, a string, or a double, and you can change between them however you want. Uh, let's say my variable, and you run it. No, apologies. You run it, points you to, it gives you this value, but you can change it however you want. Let's say string save run. It's gonna give you a string. So there is of course a way to convert the variable into another type, and it will return automatically to its default type. Like for example, if I multiply this variable by a float, it will give me a float, as you can see here, and it will of course return to its default state. So if I try, for example, to use a string instead of an integer over here, and I try this instruction, it will not give me an error, but rather a warning. And this variable is going to take the value 0, as shown over here. The argument high is an numeric multiplication at line 4. In order to read user's input, we use a scalar, an equal sign, right next to it, these two angle brackets. And then when we try to print it, let's write 23. It's gonna give me 23. One thing you should notice is that when I printed my outcome, it came with a new line. That's because these two angle brackets, not only they took my 23 input, but as well as my enter input, my new line input, which means if I want to get rid of it, I should use the chomp function and then use the name of my variable, which is input. Once I run it, I enter 23. It's gonna be just right next to it. This chomp function basically removes any white spaces there are. An array represents a list of values. We initialize an array with the add symbol, followed by the name of your array. Let's call it my array. We can define an array using these parentheses and writing inside the contents of our array. There are various ways we could access elements inside our array. Let's try to print, and we should use a scalar of our array, scalar my array, and write the index we want to access. Let's say the index 1. It's going to give me 1.36. Or we could use negative indexes as well as -1. This negative index is going very last element right into the very beginning. So if I want to print this one, I'm gonna have to use the second last element. In order to display a multitude of elements of a single array, I could use a for loop, or I could use manipulate the indexes by writing the first index I want to start with 2 dots and the last index I want to stop at, and this one will print these two. And then let's not forget that we're no longer accessing a single element but rather a multitude of elements, which means that I have to convert this scalar into an array. Once I run this, it's going to give me these two elements. If I wanted to know the length of my array, I could use a special scalar over here and then write the name of my array. I use the hash symbol over here. It's a special scalar that is by default the very last index of my array, and add 1 to it. Or I could use the scalar method and then write the name of my array. I have 3 elements. Conditions in Perl are written in the following format: keyword if, the condition, and then the instructions. You could use else if and display your other conditions, or else in order to conclude a condition. There is another way to write condition, that's by using unless and your condition. And it's practically the same thing as if not condition. In order to compare, we could use numeric operators or string operators. Let's try an example with our if statements. I have here my scalar, I called it group, I gave it 52, an integer. Then I put a condition of if group modulus 2 equals to 0, it's going to print out an even number. Now I put directly this one, I didn't bother to put it in another scalar, because it will calculate the modulus of 2 and then compare it with 0. Anyway, I'm gonna run this. It's gonna give me an even number. I could do unless over here, and let's put the 0 to 1, and it's gonna give me the same thing. Unless group 2 equals to 1, it's gonna be an even number. There is a more dynamic way to write my condition statement, That is by using the condition statement right in front of my print statement. Remove these brackets because they are no longer necessary. Then let's test it. So works. It will print even number unless the condition is an odd number. Unless the scalar is an odd number, it's going to be an even number.
In Perl, there are two different iterations of the for loop. The C-style loop, which begins with a for, followed by parentheses, followed by a declaration and initialization, a comparison which determines when the loop is going to be over, an incrementation or decrementation dependent on the initial values, curly braces, and a set of instructions. However, the range loop style begins with a for, parentheses followed by an initial value, two dots, the last value, curly braces, and a set of instructions. The C-style loop is of course the most commonly used in most Perl scripts, but considering that the range loop is the one unique to Perl, it is the one which I'll be discussing more in depth. Perl for loop can be used in a plethora of ways. Its limitations, however, that it cannot be used to decrement and doesn't give you the ability to modify its steps. This example uses the range operator to produce a list of integers from 1 to 10, inclusive. The for each directive loops over them, setting the topic variable, which is this dash, to each in turn. Perl executes the block for each integer and as a result prints the squares of the integers. Like if and unless, this loop has a postfix form. It may also use a named variable instead of the topic. For example, in this specific instance, we are declaring an I as a named variable instead of using the topic. This execution is identical to the loop that is before it. When a for loop uses an iterator variable, the variable is scoped to the block within the loop. Perl will set this lexical to the value of each item in the iteration. Perl will now modify the topic variable. If you have declared the lexical I in an outer scope, its value persists outside of the loop, like in this example. This localization occurs even if you don't redeclare the iteration variable as a lexical. For example, the range in a for loop can also be replaced with an array. This array can generate a random assortment of numbers, which will execute as such. This is useful when you want to iterate over the values of a specific list. For example, the next loop will iterate over the value of each element in implementing it by its own value. So the 0 will take a 0, 2 will become a 4, the 4 will become an 8, etc., etc. As you can see in the next execution. The 0 remained a 0, 2 became a 4, the 4 became an 8, etc., etc. The C-style for loop requires you to manage the conditions of iteration. You must explicitly assign to an iteration variable in the looping construct, since this loop performs neither aliasing nor assignment to the topic variable. While any variable declared in the loop construct is scoped to the lexical block of the loop, or will limit the lexical scope of a variable declared outside the loop construct. For example, I here is overwritten with a number. If you want to avoid this specific scenario, you must redeclare the variable inside of the loop declaration. And that is a basic overview of the two for loops in Perl and their advantages and disadvantages. A while loop in Perl is an exact copy of the C-style while loop. Syntax begins with a while, a condition, curly brackets, and a set of instructions. This is a simple example of a while loop. As you can see here, I have declared the variable named I have given it the value of 0. The while loop will keep running until I is no longer inferior to 10. Each iteration until then will say hello, and the incrementation will be by the value of 3. As you can see here, we have 4 iterations, and the value of I has changed. Unlike the for each loop, which allows us to redeclare the variable inside of its own declaration, redeclaring the variable inside of the while declaration does nothing but create an infinite loop. The while loop can also be used in tandem with an array. But unlike the for each loop, which allows us to traverse the values of the array, this results in an infinite loop. To prevent such an infinite while loop, we need to use a destructive update of the values array by modifying the array within each iteration, like this. We need to declare a variable, let's name it value, and give it the value of shift at values, which is the name of our array, and we need to say value. If we execute this, it will go through the elements of the array and then end at the last element, thus performing the same role as the for each iteration. It is also possible to move this line into the condition to perform the same exact function, as you can see here. The until loop has an identical syntax to the while loop, with its conditions after parentheses and its instructions after the curly braces, but it always reverses the sense of the tests of the while loop. Iteration continues while the loop conditional expression evaluates to a false value instead of a correct value for the while loop. But other than that, it is identical. A do block, again with the syntax very reminiscent of the C syntax, parses as a single expression that may contain several expressions. Unlike the while loops block form, the do block with the postfix while or until will execute its body at least once. This construct is less common than the other loop forms, but very powerful. As an example of the do while function, I would like to show a little block of code. We begin by declaring a variable called name, a scalar variable. Afterwards, we'll declare a do function. Inside of the do function, we'll ask the user for their input. We'll give the name variable the value that is inserted by the user. We'll use the chum function to remove any white space. We'll print on the screen the message hello with the name variable. And this function will keep looping until the scalar name is equal to the string value Muhammad. So let's test it out. As you can see here, I am being asked what my name is. If I input my name, the function will again ask me what my name is. If I input another name that isn't Muhammad, the function will keep asking me. If I insert any other value, again, the function will keep looping until I specifically insert the name Muhammad, in which case the function will exit and the loop will be over. We can also achieve the same effect by switching until with while and equal with ne, which is not equal, which will have the same exact functionality. By inserting a name other than Muhammad, it will keep looping until the value is indeed inserted, in which case it will exit. And that is a simple demonstration of the while, until, do while, and do until loops. A hash is an aggregate data structure that associates string keys with scalar values. This is the name of a variable corresponds to something that holds a value, so a hash key refers to something that contains a value. Think of a hash key like a contact list. In C, they're called dictionaries. Hashes have two important properties. They store one scalar per unique key, and they provide no specific ordering of keys. To declare a hash, you need to use the percentage sigil, like so. Hashes use the scalar sigil when accessing individual elements in curly braces for keyed access. To assign elements to a hash, you need to use the following syntax. Hashes store pairs of keys and values, with the first element being the key and the second element being the value. Perl will warn you if you assign an odd number of elements to a hash, like so. But even so, this syntax isn't very clear and can get very confusing. It's advisable to use the fat comma operator, which is this operator, instead. The fat comma operator acts like the regular comma and also automatically quotes the previous keywords. Therefore, you can use it like this, rendering the first quotes unnecessary. To access an individual hash value, use the keyed access syntax like in this example. The string Gabby is a key of the hash. As with accessing an individual element of an array, the hash's sigil has changed from percentage to a $sign. That is to indicate access to a scalar value. You may also use string literals as hash keys. So instead of the scalar name, we can use the word Gabby or the bare word Gabby. Perl quotes bare words automatically according to the same rule as fat commas, but you can still use quotes if you wish. The exists operator returns a Boolean value to indicate whether a hash contains the given key. That is useful when wanting to find out whether a hash has a specific key value you are looking for. Like in this example, if our hash favorite flavors has the key Gabby, this will return the value of true and thus enter the condition and display on the console that we have Gabby's favorite flavor, which is, and then we use keyed access to determine that value. If we repeat the same operation with a key value that does not exist in the array, with a value that does not exist in the array, like for example, Leonardo, this of course will return the value false, and as such will not execute the conditions. You can also use keys and values to store all the keys or associated values in a hash in an array. To do that, you must first declare an array. Let's call it key for our first example, equals keys of our hash. This way we can use a for loop to print out all the key values in a specific hash. The same can be done for all the values by implementing the keyword values. We can also use these keywords to find out the size of our hash, which is the number of elements from a hash, by using the scalar context on either keys or values. By declaring a scalar called size, we can effectuate the keyword keys of our hash, which will give us the number of elements of our hash. Same can be done for values. Adding a new key value pair can be done with one line of code, which is the next. This simple line of code can be used multiple times. And that will of course change the size of our hash, which goes from 2 to 4. Deletion, however, requires a function, specifically the delete function. And if we recheck the size, we'll see that it has gone down to 3. And that's it for hashes.